if you do a job in 12 hours, they're not saying what we're doing, it's just some kind of job. Again, you could say homework, and if you could work together on homework, so be it. But if you can do a job in 12 hours, and with the help of your friend, you can do it together in 3 hours. Notice it's not telling us how long it takes the friend to do it, which is why that produces this question: how long would it take your friend to do it alone? So right here, again, if you want to use a t, I like to use x's. I'm going to say x. X should pretty much always represent what you're trying to find on this one, and it's how long it's going to take. And I'll type this one in just because it's it's kind of wordy there, but this is going to be x is how long it takes your friend to do the job alone. And again, we're looking at, when we say how long, sometimes we get that mixed up with distance, especially in a lesson like this one where we're going to be looking at, well, distance with the motion applications. So I'm going to specify. This one we're looking for number of hours it takes your friend to do the job alone, all right? So once again, you got two people working on this thing. Or you got you got your pal, again, and then you can do it together. So I'm just going to put both because it's a shorter word, and I literally do not want to write all the letters. So you, your pal, and then you can do it together, right? Well, you, up here it says you can do the job in 12 hours. Now it didn't say you could do 5 jobs in 12 hours. So when I set up this fraction, my numerator, right, it's one job. You can do one job, but it will take you 12 hours. 12 hours. Your pal, it says, how long would it take your friend to do it? Again, that would represent one job. But again, we do not know how long it will take your friend to do that job. So x, I don't really need to label the x. I mean, I'll label my answer because I've already defined it as how long it takes your friend in hours. The other information that it gave us is that together you can do it in 3 hours. So that would, again, it's just the one job, and it will take 3 hours. Okay, so if you take your work and add it to your pal's work, you get both your work. And this is how that sets up for us, okay? So I'm going to rewrite this again. So I've kind of set it up with labels just so, again, we can see where stuff goes in the fractions. But they have to be set up this way, okay? Because your work it's a ratio of the jobs to hours. But think about this, if you flip all these fractions, you get 12 plus x equals 3, and then you get some kind of negative number. So it doesn't work, all right? So because your pal can't do it in negative time. So let's go ahead and set this up, all right? So I got 1 over 12 plus 1 over x equals 1 over 3. But just like we saw in that last problem, I do need common denominators so I can just wipe them out, right? And like I said in the last problem as well, I would like to see them have common x's first. Now, if you would like to focus on the numbers first, do it. I just don't recommend doing both at the same time because you can start getting things jumbled and mixed up. So I'm going to apply to the 12 denominator, I'm going to give it an x. But if I give it the denominator an x, I need the numerator to have an x as well. Same thing with the 3 denominator, it's missing the x. But if I multiply the denominator, I need to multiply it by the numerator. And again, I'll just emphasize this. This is really x over x. I've just multiplied this fraction by 1, which means I have not changed the overall value of the individual fraction. Same with this one. And it's going to work the same way with the numbers that I'm going to be applying. So I know that 12 is a multiple of 3 and this phantom 1. But so I'm not going to actually work with the 12 because it's the denominator I'm shooting for on this one. But notice that I took some time right here to actually look at this and think about it. You're probably going to have to do the same thing. Is there algorithms for this? Yeah, you could just say, well, I'm going to multiply 12 by 3, and then this 1 by 12 and 3, and then the 3 you'd multiply by 12. Now that goes back to just a quick way to force denominators to be the same. But if you do it with a little bit of thought, usually it ends up being, I don't know, decent numbers at least. So let's go and take those, and let's get them multiplied. So the phantom 1x there, I'm going to multiply it by 12. But again, if you multiply in the denominator, please multiply in the numerator. Otherwise, you've just really changed the equation. You're going to get it jacked up. So that's a 12x. See the 12x there in the denominator? This one's 12x. But the 3x right there, that's no good. Can I make a 3 of 12? Sure. Just multiply it by 4. But if you do it to the denominator, do it to the numerator as well. Right? So what does this give us? Well, let's look. Let's put this in there. So my first fraction here, so that's, again, this would be your work. You could do x jobs in 12x hours. Your friend, your pal, they could do 12 jobs in 12x hours. And then together, looks like you could do 4x jobs in 12x hours. Now, I was kind of interpreting these fractions. You don't have to, because the purpose of this whole exercise right here was to get the denominators to match. They do match, and so I'm now going to rewrite the equation, but without any fractions, only the numerators on this, okay? So here's what I get. I'll rewrite it. I got x plus 12 equals 4x. Now again, if we had started with this equation, we would have been happy, but we didn't. So here we are. We gotta finish off this equation. I'm gonna get the x's on the same side. I'm actually gonna zero out this x, so I'm gonna put my x's on the right. I commonly just put them on the left though. But I'm gonna isolate, in this case, the x's by getting them all on the same side. So I'm gonna subtract an x. It's really a 1x, I mean, if you really wanna see that, but that's gonna zero that out. Drop your 12, which now equals 4x's minus 1x's would be 3x's. And then finally here, I just want 1x's, right? So this, by the way, is telling us if your friend did the job in this many hours, they'd do 3 jobs, it looks like, in 12 hours. So I'm going to divide both sides by 3. And now I can see your friend, how long does it take him? 3. Sorry, 4. 4 is the, I almost jacked that up. Good morning. So it's going to take your friend 4 hours if they were to do it by themselves. And so unlike the last problem, I guess you're the slow one in this one. But it's good.